Hi, and welcome to another fun and easy machine learning tutorial on k-nearest neighbors. In pattern recognition, the KNN algorithm is a method for classifying objects based on the closest training examples in the feature space. KNN is a type of instance-based learning or lazy learning where the function is only approximated locally and all computation is delayed until classification. The KNN algorithm is fundamental and one of the most simplest classification technique when there is little or no prior knowledge about the distribution of the data. The K in KNN refers to the number of nearest neighbors that the classifier will use to make its prediction. Please smash that subscribe button and click that bell icon to join our notification squad. Let's take a look at how it works. To get a clear understanding of the KNN algorithm in action, let's look at a Game of Thrones example. Say we want to train an algorithm to automatically classify if an unknown person is either a Dothraki or Westerosian. You can use two features to help you classify or predict which clan the person belongs to. So for example, we can use muscle mass and wealth, treasure net worth or riches as the independent variable or features. So for the bulk of the Dothraki, let's assume they have a higher muscle mass as they are nomadic warriors. People from Westeros, however, let's assume they are a wealthier population and urban dwellers, so that the average muscle mass would be significantly lower than that of a Dothraki. So looking at our unknown person, we measure up their treasure as well as their gains. We place them around about here. And using k equals 5, we draw a circle until we have 5 neighbors in the vicinity. Now using nearest proximity, we can see that this person has 3 neighbors that are Dothraki and 1 neighbor that is Westerosian. And thus using majority voting, we can classify that the person is Dothraki. Now we don't need to use muscle mass or wealth. We can use other features such as height, waist, skin and hair pigmentation, eye color, amongst others. So the crux of the algorithm is to ask, who are my neighbors and what class do they belong to, and how many of those neighbors of a particular class are closest to me, and I will be the same class as the majority in my proximity. If we take the second example and draw a circle around here, we can classify our unknown to be a Westerosian based on majority vote. Quite simple and easy to understand. It is important to note that k should always be an odd number to avoid a draw in the votes. Proximity metrics. Mostly Euclidean distance is used for KNN, but you can use other distance metrics such as Hamming distance, Manhattan distance also known as city block, Minkowski, and Chebyshev distance amongst others. So if you look at the applications of KNN, we can use it for text mining or text categorization, which is the process of deriving high quality information from text. It is also used in agriculture for climate forecasting as well as estimating soil water parameters. In finance, KNN can be used for discovering useful patterns and correlation applications such as stock market forecasting as well as to uncover market trends. If we delve deeper into finance, we can see that it can also be used for currency exchange rate, bank bankruptcies, understanding and managing financial risk, trading futures, credit card rating, loan management, bank customer profiling, and money laundering analysis. In medicine, we can use it to predict whether a patient hospitalized due to a heart attack will have a second heart attack. We can use it to estimate the amount of glucose in the blood of a diabetic person from the infrared absorption spectrum of that person's blood, as well as to identify the risk factors of prostate cancer based on clinical and demographic variables. Let's take a look at some of the advantages of KNN. So what's nice about KNN is that it's robust to noisy training data. It is effective if the training data is large, there's no training phase, and learns complex models very easily. The disadvantages of KNN, however, is that we need to determine the value of the parameter k, which is the number of nearest neighbors. It is hard to apply in high dimensions. So when dimension of the data is high, these things happen, such as low computational efficiency, data sparsity, larger amounts of data and storage is required. We get a false intuition, which means close nearest neighbors are not close anymore, and the distance between data objects becomes less distinct. Distance-based learning is not clear on which type of distance to use and which attribute to use to produce the best results. The computational cost is quite high because we need to compute the distance of each query instance to all training samples. K-dimensional tree may also help ease computations of nearest neighbor searches. So that is it. Please don't forget to subscribe, click that bell icon if you want to see more machine learning tutorials, and please subscribe to us on Patreon. If you'd like to get the script to this video, please check out the link down below where you can download it for free. Stay tuned to the next lecture where we'll see how we can implement a KNN algorithm in Python. Thank you for watching and see you in the next lecture.